All right, so we are doing 3.3, interpreting the unit rate as slope. So I can interpret the unit rate as a slope. So a unit rate is a specific kind of rate in which the second quantity in the comparison, oh, this totally got cut off, it's the word 1. So sorry, is 1. So that's where when we went and found the slope and we got like 2 over 1 equals 2, this is considered a unit rate because my second quantity is 1, right? So anytime we have a second quantity of 1, it's called a unit rate, just a specific kind of rate. So every 3 seconds, 4 cubic feet of water pass over a dam. Draw a graph of the situation, find the unit rate of this proportional relationship. So if the time is 3 seconds, it's 4 cubic feet of water. So we have this graph over here as well. It's got some points for us. It looks like it's going by 2s, 2, 4, 6, 8, 10. So we can even look like right here, it's at 6. And these also go by 2s, 2, 4, 6, 8. So I can put the point, 6, 8. And then maybe I'm going to do 9, and then 12, and then 12, and this would be 16. So what I'm doing is I'm just moving by 3s, right? 3, 3, 3. This one's going by 4, so I'm going 4, 4, 4. And so this last one, we want to put 15, and then we move 20. So it says graph the ordered pairs from the table. Technically, we kind of already did, right? There's 2, 6. We could put the 12, 16 on there, okay? But the graph is already done for you. It's right here. So then it says find the slope, rise over run. So remember, there's a couple ways we could do it. We could do this subtraction, right, like this. Remember doing this in class? That's 3, that's 3. And then we could go here, that's 4, subtract here, that's also 4. We could subtract our points, like actually use our points. So I could go 9, take away 6, over 12, take away 8. And we would get 3 over 4. Okay, and then remember the last way is use our graphs, so they kind of did it for us. They have this rise of 8 and run of 6. Oh, you guys notice I put this one upside down. I'm going to fix that. And I would get 4 over 3, which means I need to fix this. So we're going to erase this. I did my x's over my y's. I need to do my y's over my x's, so we need to all fix this. Then we get 4 over 3. Okay? Now, if you remember from the very beginning, it said that slope is a unit rate. Unit rate is the slope. So this is 4/3 cubic feet per second. So even though our slope is 4/3, 4/3, 4/3, we can say that the unit rate is 4/3 cubic feet per, and then we would say 1 second. So I just take the slope and then say per 1, whatever the second thing is. So the first thing was y, and so that's where I got cubic feet, right? Cubic feet. And then per, and my second quantity has to be 1, so I put 1 second. So the slope's 4/3, but the unit rate would then be 4/3 cubic feet per 1 second, because I need that second quantity to be 1. All right, so the equation y equals 2 and 75/100 x represents the rate in barrels per hour that oil is pumped from well A. The graph represents the rate that oil is pumped from well B. Which well pumped oil at a faster rate? So we actually have 2. We have well A and we have well B. So it says for us to create a table, and I think that would be best for us to do is over here on our graph, because if we look at our equation right here, remember this is our constant and this is our rate right here, and remember rate is the same as slope. So the slope for well A is just equal to 2 7/75. The equation for well A was already given to us. It was y equals 2 7/75 x. What we need to do is figure out what the slope and the equation for well B is. So I'm going to make a table for well B. Okay. So we have hours here, and we have barrels here. I'm just going to put B-A-R. Oops, that's not a very good A. So there's a nice clean point right here. There we go. These go by twos, 2, 4, 6, 8, 10. So we're at 4 and we're at 10. So that's 1, right? We also have 0, 0. Let's actually add that in. 0, 0. It's right here. And then we're at 4, 10. And then if we move across here, try to see if there's another point. Oh yeah, right here at 8:20. So there's my table for well B, and what we can do with our table is we can then use it to find the slope. So I can take my 2 points and subtract, right? So I'm going to go 20, take away 10 over 8, take away 4. That gets me 10 over 2. Nope, 4. I don't know where I got 2 from. 10 over 4, which we can then reduce and get 5 over 2. And so that's for well B. So then our equation for well B, we can say is y equals 5 over 2x. But the main question is which one's moving faster, which one has a bigger rate, and it's going to be hard to compare these when they're in different forms. So let's change 5 over 2 to a decimal. So I'm going to take 2 and divide it into 5. So that's 2. Pen is having issues today. We're going to add a decimal, bring down our 0, and 2 goes into 10 5 times. So this is the same as y equals 2.5x. So now that we have their slopes and we have their rates and all those good things, we can compare them. And so if well A is moving at a rate of 2 7/75 and well B is moving at a rate of 2.5, which one is pumping oil faster? Well, our answer would then be well A. All right, Thomas rides his bike at a steady rate of 2 miles every 10 minutes. Graph the situation, write the unit rate of this proportional relationship. So let's make our table first based off this information. So we're going to have miles and minutes. So we're going to do, and if you look at our graph, it tells us that minutes is x and miles is y. So we're going to do minutes here, miles here. So 2, 10, maybe we jump to 4 and 20. We could do 6, 30. Okay. Now these are technically our points, And it also does tell us that it's proportional, which means it goes through 0, 0. So we can add that as part of our table. It's not in order, but that's okay. So I'm going to put 0, 0 here. These just go by 1, so 1, 2, and all the way up to 10. And really that's all we can graph because the graph doesn't have any more room besides that, right? So that's all I can graph, so I'm going to connect these points like so. So there's Thomas's graph for his ride. So remember, unit rate is the same as the slope. So we need to find the slope. So I'm going to take 2 of my points and subtract. So I'm going to go 20, take away 10, over 4, take away 2. We get 10 over 2, which equals 5. And then remember, for our unit rate, we just put 5 miles. There's my first quantity, right? I mean, yeah, my first quantity is always this, per 1 minute second quantity. And that's because, remember, slope is y's over x's. So it's miles per minute, right? So 5 miles per 1 minute. That's because our slope was 5. So then our equation is just y equals 5x. All right, this is another comparison problem. So we have the equation y equals 375x represents the relationship between x, the time a plane flies in hours, and y, the distance plane flies for in miles for plane A. So this equation is for plane A. The table represents the relationship for plane B. So this one is plane B. Find the slope of the graph for each plane and the plane's rate of speed. Determine which plane is flying at a faster rate of speed. So maybe pause and see if you can do this. You need to go find the slope of A, slope of B, and then determine who's flying faster. This is very similar to this question. So you can reference this question from the other page to see how we compared A and B. So pause, try this, see how it goes. All right, for plane A, our slope is already right here in our equation. So slope of A is 375. We could say it's 375 miles per 1 hour. Okay, so remember, that's how we change our slopes into unit rate. So for plane B, we would need to find the slope between these points. Okay, so I'm just going to pick 2 points. I like to always pick my smallest, so I'm going to go 850 minus 425 over 2 minus 1. Well, 2 minus 1 is nice and easy. That's just 1. And then we're going to go borrow 10 take away 5 is 5. 4 take away 2 is 2. And 8 take away 4 is 4. And so there's the slope. So it's 425. We would say its unit rate is 425 miles per 1 hour. Now that we have them in the same, right, per 1 hour, we can compare them. And so hopefully you said plane B. Okay, so things to remember. Unit rate equals slope when run equals 1, or when it's the x equals 1, right? All right, so here is a table. They want you to find the equation of the table, and then they want you to write the unit rate specifically for this relationship. Okay, it doesn't say what the distance and the time is, so you can just say distance per time. That's fine. All right, until next time.